today we're gonna be doing a question from 7.2, and we're gonna be finding the exact value of sine of 105 degrees. So to find this, we first need to find angles, equal to 105 that we know the exact trig functions to. So we know the exact trig functions to 60 and 45, and those happen to equal 105. So we would write it as 60 plus 45 degrees. And so now that we have 60 plus 45 degrees, we'd use the correct identity, which in this case we would have to use sine A plus or minus B is equal to sine of A cosine of B plus or minus cosine of A and times sine of B, right? So now we would just need to put in so 60 would be A and 45 would be B. So now we just have to plug it into this identity, which would look like sine is 60 cosine 45. And then in this case, it would be, since we're adding these 2 degrees, we'd have to use the positive. So we'd use the addition. So we'd use addition to fill this out. So it would be plus cosine 60 degrees and then sine 45. So now we have sine of 60, cosine of 45 plus cosine of 60 and sine of 45. So now that we have this, we just look at our unit circle and find the sine of 60 degrees and the cosine of 45. And so when we do find this, the problem would look like something like this. It'd be square root of 3 over 2 times square root of 2 over 2, and then be plus 1/2 times square root 2 over 2, right? So now we would just multiply these, and then, so if we multiply the square root of 3 times the square root of 2, we'd get 6. If we multiply the denominators, we would get 2, since, they say the same, we have the same denominators. And then we multiply 1/2 the square root of 2, so we'd get square root of 2 over 2. And then we just add these. So when we add them, we cannot add if they're not like radicals. So we just leave them, and so it'd be square root of 6 plus square root of 2 over 4. And that would be how you find the exact value of sine 105. And it'd be this right here. And that's how you solve this problem.